Hi everyone. Today we'll build an AI agent with externalized prompt delivery pipeline together, step by step. First we'll create it in Genum Lab, then we'll connect it to n8n for automation. It's going to be simple and fun. Before we start, let's talk about why prompt development is so important in the Gen AI world. AI isn't just about generating text anymore. Today, a lot of real business logic actually lives inside the prompt. And that's where the real magic happens. Here's the big trend. LLMs are getting smarter and smarter. More and more we're moving the logic into the prompt itself. And it goes even further. We now see next-gen orchestrators emerging where even the orchestration logic is being shifted into prompts. At Genum, we like to say, prompt eats code. That's exactly why we need a strong foundation for prompt delivery. Genum acts like the DevOps layer for AI, ensuring your AI logic is delivered with standards, tested for reliability, and ready for real-world use. Think of it as a CI/CD pipeline, but built specifically for prompts. So let's jump into Genum Lab and see it in action. In Genum Lab, we'll open our prepared demo project. We have role-based access here. So in a real organization, different people can have different roles and permissions. This makes the configuration flexible and secure. The example we're working with today is a very common task, the kind of work first-level support teams do every day. Normally, a person sits there, reads the incoming request, figures out what it's about, creates a ticket, assigns a priority, and routes it to the right team. This is exactly the kind of repetitive, rules-driven work where Gen AI can step in. But for that to work in the real world, the logic behind it has to be tested, verified, and easy to extend. That's where Genum helps. For today's demo, we'll use the ticket router use case. I've already set up the business logic so we can focus on how it works. If you look at it, it's almost like programming. You have mapping rules that define how the system should behave. We have categories like technical, billing, sales, and human resources. We also have different priority levels. And here you can see exactly how the mapping works. For example, if the priority is high, the ticket is always routed to the escalation team. In all other cases, the system determines the team from the context and maps it to the right recording channel. That could be Slack or any other back-end notification system. So this is the core idea. Take a real-world support workflow, move the logic into a prompt, and let Genum help you manage and test it. Another key thing in agentic integrations is the tools, the parts of the system that call your backend or trigger actions based on the context the AI provides. In Genum, managing these tools is straightforward. We just head over to the model settings. In our example, we're using Gemini, mainly because it gives us great processing speed for this workflow. And for this demo, we only have one function. This function takes 4 things from the context: the incoming text, the channel, the category, the priority. All of these values are generated dynamically based on the input and the prompt logic. For example, priority has its own mapping rules. The Gen AI model, guided by our prompt, runs a semantic analysis to figure out how urgent the request is. It also factors in some business rules, like time until decision. So if the decision is needed within 24 hours, it's marked as urgent. If it's within 7 days, it's medium. So here's where you really see the power of Genum in action. As we said earlier, our goal is to eventually build this AI assistant into n8n. But before we get there, we're doing something important. We're separating the logical unit, the prompt, from the execution layer. In other words, we're decoupling it from the runtime environment. Why? Because once it's independent, we can test it in isolation and make sure it works exactly the way we expect. So let's do that. We take the prompt we created and run our first test case, providing input. Urgently start the production server. The model processes this and correctly assigns it to the technical category. It also marks the priority as high. Because of that high priority, it routes the task straight to the escalations team. Perfect. Exactly what we want. Now, to make sure this behavior stays consistent in the future, I'm going to save this output as the expected value. So we save the first test. That way it becomes part of our static test cases. Now we go to the next test. Right now, we're simply verifying the basics, making sure a prompt actually works as intended. Here's our next test case, another urgent request. But this time, instead of technical, it correctly assigns it to the sales category. Because it's still urgent, it routes it to the escalations team. Perfect. That's exactly what we want to see. Next, we're expanding our test coverage. We run another case. Medium priority, still in the sales category. And yes, it works perfectly. This step is important because we want to verify and fine-tune the prompt before connecting it to any external tools. For the final example, we test a case where the deadline is 5 days away. This should also be medium priority in sales. And sure enough, it works exactly as expected. So after this first run, all our tests are passing. You might be thinking, great, the prompt is rock solid, but here's the catch. With Gen AI, the same input doesn't always produce the exact same output. From run to run, results can vary. That's exactly why Genum includes regression testing. This lets us rerun all our tests and re-verify the results at any time. At this point, we have two paths. We can either fine-tune the logic and add new business rules, or we can move forward and integrate the tested prompt into another tool. My recommendation for now? Let's move on to n8n. We've proven the prompt works. And while we could add more logic directly inside it, that's outside the scope of today's video. Let's head over to n8n, where I've already prepared a sample flow. Later on, you could integrate it with emails, backend databases, ticketing systems, whatever fits your workflow. The interesting part is the Genum Node. This is available right in the n8n community nodes. Just type Genum and you'll find it. This node lets you pull in your tested prompt directly. In our case, we select Ticket Router from the dropdown. This is our demo prompt we've just tested in Genum. This way, we're injecting our Genum tested prompt directly into the AI agent. Inside the AI agent, we pass that prompt value along with the same Gemini model we used earlier in testing. In this demo, the Create Ticket tool is implemented as Subflow is just a placeholder. It always returns true and doesn't have any real functionality yet. But even with this placeholder, we can still run or rerun our test cases to make sure the prompt still performs exactly as expected. When we check the node's output, we can see it processed the ticket correctly. Correct category, escalation channel, and high priority, just like in Genum testing. What we've really shown here is the power of decoupling the brain, the prompt logic, from the execution orchestration layer. This is a best practice. Over time, you'll have more and more AI use cases tied to real business needs. With Genum, you can always test your prompts outside the live execution environment and keep running regression tests to make sure nothing breaks. That way you can re-verify old tests, confirm everything is still working, and avoid costly fixes. And if something does break, you can simply fine-tune the prompt, rerun regression tests, and send the working version to your orchestrator like n8n. This is critical in real-world business. When your AI is making decisions that could affect revenue, you need stability and predictability. That's exactly what Genum delivers. Thanks for watching, everyone. I'll see you in the next video. Bye.